ran out of room. Okay, let's say we're going from the big triangle to the little triangle. Which one's the big one? We'll say the big one is this BCD. And the little one is this BAE. Oops, triangle. Okay, so these triangles are similar if their sides are proportional. Let's check. They might not even be proportional. Okay, let's see. We're trying to figure out when I go from 4.5 to 4, what happens? And when I go from 6, the bottom piece of the triangle, to 3, what happens? Okay, well, I think you can tell. When we go from 6 to 3, we divide by 2. Am I right? Yeah. What about when I go from 4.5 to 4? Is 4.5 divided by 2? It's supposed to be 4. So these suckers are not similar. Woohoo! Because we can't multiply or divide by the same scale factor. Alright, let's keep going. Just got some more triangles. Let's see here. Part A says find x, okay? And then at the bottom, it says that one of the triangles is a little squiggle. The other triangle, that means similar. Okay, so we want to find x. Well, let's go ahead and separate my two triangles. It looks like I got a small triangle with 2 and x. Then we got a big old triangle. See that smaller triangle? 2 on the left, x on the right. Yeah, okay. The bigger triangle has 2 and another 2. Oh no, that's 2 plus 2 equals 4. And then on the right side, what do we have? We have x and a 7. X plus 7. Oh gosh, that looks kind of weird. Okay, so we have to use our scale factor. Okay, let's try and figure out our scale factor. Okay, using numbers. So I'm not going to look at the part with the x plus 7 or the x. Just look at the part with the numbers. How do we get from 2 to 4? You multiply by 2. Yep. Okay. So that means that to get from x to x plus 7, we have to multiply by 2. So that means to go from the smaller triangle to the bigger triangle, the smaller triangle has the side x. The bigger triangle has the side x plus 7. Okay, so that means to get from this left guy to the right guy, we're going to use our scale factor of multiplying by 2. So this x on the left multiplied with a 2 equals that x plus 7 on the right. Okay, you might be thinking, wait a minute, I thought the sides were not equal to each other. And that's correct, they're not. If they were equal to each other, then there wouldn't be this times 2 up in there. So to get from the left side to the right side, so from this x of the first triangle to the x plus 7 of the second triangle, you have to multiply by 2. Okay, now let's do some algebra. X times 2 is 2x equals x plus 7. Okay, get x by itself. I think I'm going to take this lonely naked 1x and subtract it over. Cankle. And we get x equals 7. Yeah. Okay, so the question was to find x. Well, we just did. So that means that this smaller triangle has a side of a 7. This bigger triangle has a side of x plus 7, or 7 plus 7, and that's 14. Hot dog, that's a scale factor of 2. We did it right. 7 times 2 is 14. Whoa. Okay, again, let's look at this guy. Oh my goodness. Okay, they're upside down. Alright, first we need to figure out what sides correspond to each other. Okay, so it looks like the side in between the double and the single little slash mark, yeah, the side in between those is x. Okay, so let's look for that same side on this triangle. We're going to look for the two angles that have the double E and the single slash mark. So here's the double E and the single slash mark E. Okay, good. Then we're going to look for the side in between those two angles. Well, the side in between these two angles is ocho. Yeah. Okay, then let's look at this side that has the 5 on it. The side that has the 5 on it comes from the angle that's double ticked and the naked angle with nothing drawn on it. So let's look at this triangle. This triangle, the side that matches the 5 is the side that has the double ticked angle, which is this side, double tick mark, yeah, all the way to the naked angle without anything written, so that E is the naked angle. Okay, so let's see here. It says we're going from ABC to EDF. Well, first let's figure out our scale factor. We're saying 5 times something gives me this 7. Okay, well, if I get x by itself, I divide by 5, and we get x equals 7 over 5. So that's my scale factor. Maybe I should have used a different letter. Sure, I'll just use y, because I'm about to use x again, and I might have just confused y'all. Okay, so we just found our scale factor. To get from 5 to 7, to get from 5, there's 5, you have to multiply by 7 over 5 times 7 by 5. Hey, and that's how we got 7. Okay, so that's our scale factor. Now, let's find x. Okay, we know that x on this smaller triangle times something gives me the 8 from the larger triangle. And it's x times whatever your scale factor is. So on this last example, my scale factor was 2. So that's where I put the times 2. Our scale factor is 7 over 5. So we're going to say 7 over 5. Okay, well, let's get x by itself. To get x by itself, we have to divide by 7 over 5. And when we do that, we got to do that keep, change, flip thing, where we keep the 8, we change the division bar, we flip that fraction upside down. So let's see. We keep the 8, we change the division to a divide bar, we flip that last fraction upside down. Okay, now we multiply. When you multiply fractions, you go left to right. And I think I'm going to put my good friend Juan down there. Hey, Juan. Hey. times 5 over 7. And that makes 8 times 5 is 40 over 7. Hey, 40 over 7. X equals 40 over 7. And you cannot reduce that. And don't write like 5 and 5/7 or something. Don't write a mixed number. Just keep it nasty. Okay, let's keep going. Let's look at this next one. It says a student wants to know how far above the ground the top of a leaning flagpole is. At high noon, when the sun is almost directly overhead, the shadow cast by a pole is 10 foot long. The student holds a plumb bob, I have no idea what that is, with a string 3 feet long up to the flagpole, and determines that the point on the plumb bob touches the ground at 15 inches from the base of the flagpole. How far above the ground is the top of the pole? Okay, I didn't really know what a lot of these words were, but they give you a picture, and on the homework they give you a picture too. Okay, so what it's saying is there's a flagpole. Here's the flag. Yeah, and it has like a flag like hanging down. See? Yeah, that's our flag. Woo, woo. So that's the pole, okay? Then it says there's a sun up in the air. I think my sun's on the wrong spot. Then it says there's a sun up in the air. And suns make shadows on the ground. So this thing on the ground is a shadow. Okay, high noon means it's almost straight up. Okay, it's talking about this plumb bob. I don't even know what that is, but it says it's 3 feet along up the flam. Okay, well, the numbers are there, so woohoo. Okay, let's see here. It says how far above the ground is the top of the pole. So we want to know how tall this huge thing is. Well, first, let's draw the two different triangles. Okay, so we want to know the really tall piece. For the bottom of the big triangle, we know that it has a 10-foot shadow. We know that up and down of this smaller triangle is 3 feet. And usually we don't care about the labels of feet, but this inches thing is going to mess us up, so we have to convert that. Okay, and then it says the bottom triangle is 15 inches out. Okay. Okay, the issue is these are not all inches, and they're not all feet. So before we can even do the math sorcery we've been doing, we got to try and convert this to maybe a decimal or something. Okay, so let's maybe figure out what this 15 inches is. That's definitely, how many inches are in a foot? 12 inches in 1 foot. Okay, so this sucker is definitely 1 foot for sure, right? 1 foot for sure, because there's 12 inches in a foot, and there's 12 in 15. Okay, and then how many are left over? 3. So there's 12 inches in 1 foot, so this is definitely 1 foot, but there's 3 left over. And to do 3 left over, we say 3 on top of 12. The 3 is what's left over. The 12 is how many total inches there could be. Okay, so this is 1 3/12. How else can we reduce that? We can turn that into 1 1/4. And what is that as a decimal? 1.25. Oh, goodness. Okay, now that we have that 1.25 feet, we can do our thing. Alright, so we have to ask ourselves, what is the scale factor? Okay, well, to get the scale factor, we take matching pieces of the triangle, which are the bottom pieces, and we say, to get from one to the other, what do you have to do? Well, we take 1.25 from the small guy, and we have to multiply him times an x to get this 10 on the right. It's just like that formula we used on the last two examples. Only this time we're saying the smaller measurement is 1.25 times something we don't know to get 10. Okay, now let's get x by itself. We divide. And we get x equals 8. Okay, that is not the height of the triangle. That's the scale factor. Okay, now let's find the actual height of the triangle, or how far above the ground is from the top of the flagpole. Okay. Well, the smaller triangle has a height of 3, and we're going to multiply that with whatever the scale factor is to get the new height. So, 3 of the old triangle times 8, which is our scale factor, gives us 24. So the height of this triangle is 24. What measurement are we using? Feet. Yeah. Alright, let's keep going. Let's look at this last sucker. It says find x and y. I think we've already done a problem like this on the page before. So we'll go ahead and stop here.